We look around the universe and it looks like we're in the center.
Since the Big Bang, the cosmos has been expanding in all directions at an increasing rate. Every day, the distance between galaxies becomes bigger. Things are currently drifting away at a speed of 2.2 million kilometers per hour. You'd expect that the galaxies to our left and right would be traveling at the same speed. You'd be mistaken. What's slowing us down are enormous clumps of matter. Matter attracts matter, which is why galaxies form clusters and superclusters. However, that is not nearly enough in light of the results that astronomers have been obtaining from their computations. Somewhere out there in the most heavily veiled area of space lies a massive gravitational irregularity. Over the course of billions of years, it's been pulling us and all the galaxies near us closer to it. However, astronomers may have discovered something even larger and stranger. What exactly is this mysterious force, and will it destroy the entire universe? In this video, we investigate this strange irregularity that is devouring everything in its path. Our small planet is locked in the tremendous gravitational orbit of our local sun as we hurtle through the stars. This celestial body keeps us spinning all day. In fact, you're traveling at around 1,000 miles per hour right now as a result of a combination of forces. Isn't it crazy? However, there's something strange going on in space that isn't limited to the Milky Way. In fact, the majority of our observable neighbour galaxies appear to be impacted as well. Something 150 million light-years distant is attracting all of these galaxies, but no one knows exactly what it is. The disk of our galaxy, which is filled with gas, dust and stars, obscures the view from Earth on that side of the Milky Way. This area has been dubbed the zone of avoidance by astronomers, and something known as the Great Attractor is located deep within that zone. Scientists were able to peer inside the zone of avoidance thanks to advances in X-ray and radio astronomy. Our Milky Way and the adjacent Andromeda galaxy were discovered to be migrating toward the center of the local group of galaxies, which is located in the Virgo cluster. They all glide together toward the core of the Laniakea supercluster. The Great Attractor is the attraction zone in the center of this giant cluster. It has an estimated diameter of 300 million light-years and a central distance of 147 million light-years from Earth. Behind the cloud of gas and dust, astronomers discovered a massive supercluster of galaxies known as the Norma cluster. It has a total mass of around 1,000 trillion solar masses. However, astronomers doing an X-ray investigation as part of the Clusters in the Zone of Avoidance project showed that the Great Attractor area contains much fewer galaxies than originally assumed. The Great Attractor was thought to be 1,000 trillion times the mass of the Sun. However, researchers discovered that its mass was barely 1/10 of what experts had estimated. The Malmquist bias was found to be responsible for the majority of the visible galaxies in the area. The greater the distance in space, the higher the number of things that will be too faint to detect. As a result, only the brightest objects were visible. Because of this, we wrongly identified such objects with areas of the sky where they do not belong. As a result, denser galaxies appear to fill particular parts of space. So, in many respects, the Great Attractor may be a mirage, presenting us something that does not exist. It could not be a super attractor after all, but rather a region of space with more galaxies than normal. The Great Attractor's mass is insufficient to draw local clusters of galaxies. So what drives them to the heart of the Laniakea supercluster? In pursuit of explanations, scientists began looking for a structure with a stronger gravitational attraction, and they eventually succeeded. This is the Shapley supercluster, a grouping of around 20 clusters containing 8,000 galaxies located about 650 million light-years from Earth. This supercluster has a total mass of 10 million billion solar masses. Within a billion light-years of the Milky Way, it is the most enormous structure. The ESA's Planck spacecraft has already captured unprecedented photographs of the core part of the Shapley supercluster while scanning the sky for the earliest cosmic light. Galaxy clusters Abell 3558 on the right and Abell 3562 on the left together with a few smaller groupings in between, may be seen as the brightest pink patches. Scientists have also built a model of a structure facing the opposite direction as the Shapley supercluster. There, astronomers found the dipole repeller, a region with extraordinarily low density. The Shapley supercluster's enormous gravity drives celestial bodies out from this area of space. As a result, the dipole repeller is most likely devoid of matter. Because underdense parts of space repel matter as much as dense regions attract it, the dipole repeller is also related with the flow we see. However, even the discovery of the massive supercluster Shapley has not revealed the overall pattern of the gravitational web in the vicinity of the Great Attractor. Professor Matthew Coles of the University of Australia argues that a portion of the Milky Way's velocity is still unexplained. The researchers arrived at this conclusion after measuring the gravitational forces of the Virgo cluster, the Great Attractor, and the Shapley supercluster, and the results do not add up. It was discovered that our galaxy should travel at a rate of roughly 50 kilometers per second, 31 miles per second. Professor Coles believes it's because of the mysterious structures concealed behind the Milky Way, and scientists may have discovered at least one of them, the Vela supercluster. It's around 850 million light-years away from Earth, hidden under a dense covering of dust and gas. The cluster is massive. It spans around 370 million light-years and comprises over 100,000 galaxies. Each one is surrounded by hundreds of billions of stars. If its size is verified, the supercluster might be the biggest in the Milky Way's neighbourhood. The gravity of the Vela supercluster might explain the discrepancy in speed between the Milky Way and that induced by universe expansion. In the meanwhile, astronomers have investigated 883 galaxies in the zone of avoidance, 1/3 of which have never been detected previously. The study was carried out using the Parkes radio telescope in Australia. First, astronomers discovered 3 galaxy concentrations, NW1, NW2 and NW3, followed by 2 more clusters, CW1 and CW2. Each galaxy has 100 billion stars on average, and discovering hundreds of galaxies lurking behind our own implies a tremendous amount of mass that astronomers were unaware of. It's possible that their gravity influences the movement of the galaxies around them. This, however, does not put an end to the enigma. The Milky Way continues to move faster than it should. Scientists are still looking for hidden sources of gravity, as well as determining the nature of the Milky Way's and other local group galaxies' motion. One theory is that dark matter is at work here. Its hidden clusters may attract galaxies with gravity just as well as large formations of ordinary matter. Alternatively, galaxies might be driven by another hypothesized force of the universe known as the dark flow. This is the term given to the surprising motion of galaxy clusters, frequently toward an unknown mass outside the observable universe. NASA Goddard Space Flight Center scientists uncovered evidence of this phenomena by studying data from the Wilkinson microwave anisotropy probe on over 1,000 clusters. This is massive research that encompasses a vast portion of the observable cosmos. According to the paper's authors, the dark flow stretches farther into the universe than previously imagined, 2.5 billion light-years beyond our solar system, and it travels toward the Great Attractor, followed by the constellations Centaurus and Hydra. According to one explanation, this enigmatic black flow is linked to another world in a possible multiverse. It is hypothesized that our universe arose from one of the fundamental energy field's bubbles. If this is the case, many other universes might have emerged from other bubbles, and the dark flow may have been caused by the gravitational attraction of some mass from another universe. Scientists are genuinely thinking about this hypothesis since there is an ongoing discussion over it. Meanwhile, an international team of astronomers undertook study on the Great Attractor. They tracked the movements of 10,000 galaxies and clusters located within 350 million light-years of Earth. Scientists tracked the movement of galaxies from when the universe was just 1.5 billion years and to the present day. Based on their present brightness and position in space, they computed the paths of galaxies from the Milky Way. Based on the findings, the researchers created an interactive model that depicts the Great Attractor, the Virgo cluster, and the Perseus Spices supercluster. The model depicts the movement of clusters and individual galaxies toward the center of attraction. Most crucially, astronomers predicted the fate of all these celestial bodies, including the Milky Way. They discovered that the universe's accelerated expansion prevents most clusters from traveling to the centers of gravity. Scientists have even created an interactive simulation of the future paths of galaxies in this region. The model spans a time period ranging from the early birth of galaxies to a time when the universe will be nearly twice as old as it is now. According to the study, only a few big mergers in very dense clusters will occur during the next 10 billion years. For the time being, we know that space is a tremendous mystery, and answers frequently raise additional questions. The Shapley supercluster's closeness to neighbouring clusters compels some researchers to pause. Some argue that a huge gravitational anomaly is a realistic answer to the Great Attractor because that many galaxies gather together in various clusters, openly contradicting the Hubble flow. Theories have ranged from a supermassive black hole greater than anything we could comprehend to aliens. Scientists do not believe a supermassive black hole is a viable answer to the Great Attraction. The rates at which galaxies move do not appear to imply this. All the superclusters mentioned earlier are moving at a seemingly normal rate, not one which would be influenced by a supermassive black hole. Another popular theory is alien civilizations, but we can rule that out by asking the simple question, why would they want to attract all these galaxies to themselves? However, what are your thoughts? Do galaxy clusters seem to be the answer to you? What is the true mystery behind the Great Attractor? Let us know in the comments section below.